Hello everyone, I am Himanshu Majan from Team 6 Kharghar Denary Blinders. So today we will discuss about JVM, JRE and JDK and more about JVM architecture. Though this is a very basic topics, but many interview questions are framed on this. So let us discuss that. Let me share my screen. So initially we will see what is JDK, what is JRE, what is JVM. So when someone says, I have installed Java 17 in my PC, I have installed Java 19 in my PC. So what does that mean? It means that he has installed JDK version of JDK 19 version in his PC. He has installed JDK 17 version in his PC. So JDK is Java Development Kit. Java Development Kit has JRE and development tools. So what is JRE? JRE is nothing but Java Runtime Environment. Java Runtime Environment has JVM and other set of libraries in it. So when it comes to who will install JDK, who will install JRE in their systems, let us consider one situation, one scenario. If HDFC Bank says me to develop an app for them, if I am a developer, I need to have JDK installed in my system. And HDFC people will have JRE installed in their PC. As they are not going to develop any code for it, they are going to run the application. So they need to have Java runtime environment to run that application. But as a developer, I need to have development kit. So what additional I get? I get development tools along with JRE. So that is the case. Further, what is JVM? JVM is a Java virtual machine. Java virtual machine is nothing but it is a virtual machine. It doesn't have any physical existence. It is a core part of Java. Without JVM, we cannot do anything. So let us understand what is JVM architecture. So whenever we write a Java code and when we compile it using Java-C, one .class file gets generated. That .class file is nothing but a bytecode. That bytecode is a source code for a JVM. So when it comes to a JVM architecture, there are three main components. First is class loader subsystem, runtime data areas, and execution engine. So talking about first component, that is class loader subsystem, there are three components: loading, linking, and initialization. In loading, there are three parts: Bootstrap class loader, extension class loader, application class loader. Bootstrap class loader is responsible for loading and Bootstrap class path files. That is nothing but rt.jar files. These have just a compiled classes that gets loaded first. Let me tell you, Bootstrap class loader has the highest priority in loading. After that, extension class loader gets activated. Extension class loader is responsible for loading the classes which are present in extension folder, which are predefined libraries. Other than that, there is application class loader. Application class loader, it is responsible for loading a application which is responsible for loading a classes present in a application class path. Further, we have a linking. In linking, we have three components: verify, prepare, and resolve. In verify, bytecode verifier will verify the generated bytecode, and it will check whether the code which is written in bytecode it is proper or not. If it has some problems, it will give us a verification error. Next part is prepare. In prepare, static variable gets a memory, and static variables are assigned by their default values. And in last part, that is resolve, all the symbolic memory references are replaced with the original references. And next part is initialization. This is the last phase in class loading. All the static variables are assigned with the original values, and the static, if there is static block, then that will be executed in this phase. So that is all about class loader subsystem. Next is runtime data areas. It has 5 main components. First is method area. In method area, all the class level data will be stored here. All the static variables are stored here. And let me tell you, there is only one method area per JVM. So it is a shared resource, we can say. Method area and heap area, both are the shared resource. Heap area contains all the objects and their references and arrays that are stored in the heap area. Also, heap area is also one per JVM. So it is also a shared resource. Talking about stack area, in stack area, whenever a method is called, one thread is generated, one stack frame is generated. And in that stack frame, there are 3 components. That is local variable array. This OS stand for operand stack and FD stand for frame data. In local variable, all the local variables for that method are stored. In operand stack, whenever if any function need to do some operations, local operations, then this operand stack will provide an workspace to perform the operation. And talking about frame data, this if any exception is raised in our program, then the catch block information will be stored in this frame data. And so talking about PC registers. So what are PC registers? PC registers are also PC registers stores the instructions that to be executed by a thread after the current execution of a thread. So PC registers will be updated with the next instructions. And lastly, we have native method stacks. The native methods mean methods which are written in other languages than Java. Mostly they are written in C and C++ languages. These native methods are required sometimes to execute our code. So this is a native method stacks which are stored in that. And our last part is execution engine. Execution engine have interpreter, interpreter, then JIT compiler and garbage collection. So what interpreter does? Interpreter interprets the byte code, but its execution is very slow. The disadvantage of the interpreter is that when one method is called multiple times, it interprets it every time. So every time a new interpretation is required. So to overcome this disadvantage of interpreter, JIT compiler has been introduced. In JIT compiler, JIT compiler helps interpreter to convert the bytecode. So when the same code is executed multiple times, what JIT compiler does is JIT compiler convert the code in native code and uses it for repeatedly execution of the code, same code. So it has a 4 component: intermediate code generator, code optimizer, target code generator, and profiler. What intermediate code generator does? It produces an intermediate code. It just produces one code. Then code optimizer is responsible for optimizing the intermediate code. And then target code generator, it generates a machine code. And profiler, what profiler does? It is a special component which identifies the method which is called multiple times or not. If the method is called multiple times or not, this is the work for profiler. And then we have last component as garbage collection. In garbage collection, all the unreferenced objects are get removed. And if we want to remove object or any unreferenced objects explicitly, then we can do that. We can do that using garbage collection, but it is not guaranteed. We need to use some system.gc method for that, but it is not guaranteed that that method will be garbage collected. At the end of the execution of any Java program, this garbage collector will execute. So in last, we have this Java native interface and Java method libraries. So what this Java native interface does? This provides the native libraries required for the execution engine. So whatever codes, native libraries are required for execution, this will provide by Java native interface. So that is all about JVM architecture. I hope everyone has understand a little bit of it. It is a very, very important topic from interview point of view. Many questions are framed on it. So try to understand all the concepts of JVM architecture. Thank you.